Okay, so we started problem number 1. We have a 34-foot ladder propped up against a building all the way to the top. They tell us from the bottom of the ladder to the bottom of the building is 25 feet. We've drawn that already. And we want to figure out how tall is the building. So this right here. All right. So let's figure out that height. We got a Pythagorean theorem. We have to assume one thing though. The ground and the building form a right angle. Okay. We have to assume that because now we have a right triangle there, and we can say, okay, this is our hypotenuse. Let's say this is A. We're going to figure out B. Okay. If we have all of that, we can set up a Pythagorean theorem situation. All right. So let's go ahead and do this. 25 squared plus B is the part we don't know. So B squared equals 34 squared. Okay. And let's see. 25 squared is 625. B squared equals 34 squared is 1,156. Okay. And so now we have to get B by itself. Let's subtract on both sides. Take away 625. And so B squared equals 531. And I want B, not B squared. So we want to undo the square root, or the squaring with a square root. And that's the part I don't know. I'm pretty good, but I don't know the square root of 531. Other than it should be less than 34. Okay, so let's see here. 27. Let's find out. Square root. Oops, let's turn you on. 531. 23. 23.04332. Okay, so we're rounding this to the nearest tenth. It's 23, right? 23. Technically 23.0, but we would write it as 23 feet. So let's write that down. The building is 23 feet tall. Okay. Yeah, we just figured out the height of the building indirectly. All right. For the next question, you really have to know your bearing, north, south, east, west. You guys know about that? Well, let's read the problem first, and then we'll talk about that. Is anyone still writing this one? Copying anything here? Okay. So it says you start driving east for 5 miles. So I'll be highlighting this stuff. So we're going east for 5 miles. Turn left and drive north for another 12 miles. At the end of driving, what is your straight line distance from your starting point? What is your straight line distance from your starting point? Round to the nearest tenth of a mile. Okay. So to get an idea of what we're talking about, I'm going to just draw a quick directional here. Kind of like what you see on a map sometimes. North is always here. Opposite north is south. On the left, it's west. To the right, it's east. Okay. So that'll help us figure out where we are. We have a starting point. Let's say there. So we're going to start here. That's where we start. And what do we have to do first? We start driving, we go east for 5. So arbitrarily, I'm going to say I got to go in this direction. Let's say that's 5 miles. Then from there, I have to go north for another 12 miles. I shouldn't have made this so long. This isn't going to be drawn to scale. So this is where I end up. And so I went north for 12 miles. Okay, so technically this should be a little shorter, but all right. And it says, what is your straight line distance from your starting point? In other words, from here to here. Sometimes we say as the crow flies, just the straight distance across. Well, let's assume we made perfect right angle turns. Another Pythagorean theorem situation. First thing we should do is figure out where our hypotenuse is. That's C. Call the other ones A and B, whichever one you like. So I'll call this A, I'll call this B. And let's use the Pythagorean theorem to figure this out. A squared plus B squared equals C squared. Okay. So let's replace A and B with 5 and 12. 25 plus 144 equals C squared. And that's 169 equals C squared. And so I have to figure out the square root of 169, which is a perfect square, actually. It doesn't give us an irrational number with all those decimals. 13 times 13 is 169, so C equals 13. So the straight line distance is 13 miles. There you go. Let's try the next one. We talked about a little bit about it yesterday. Emily, would you read that for me, please?
The Sony television is advertised as a 62-inch TV, the diagonal length. If the width of the TV is 38 inches, how tall is the TV? Round to the nearest tenth of an inch.
Okay. Diagonally, and that's what they tell us right there. It is. It's just an advertise. They have to pick a number to give you, and they're going to give you the largest number they can they can legally say. Okay, so we know it's advertised as 62 inches. That's a diagonal length. The width of the TV is 38 inches. Let's draw that. Let's draw that TV. So okay, let's see that. Say that's our TV screen, and diagonally, that's 62 inches. What's our other dimension that we know? Wide. Okay, so let's say that's this. Hello. Got something for me? 1 second. So, again, we're assuming it's a rectangle. All corners are 90 degrees. Well, let's label our sides. This is C. Let's call this A and B. Okay. Let's say A squared plus B squared equals C squared. So 38 squared plus B squared equals 62 squared. So we have to square 38. 1,444 plus B squared equals 3,844 is 62 squared. Okay, so now we got a takeaway. Subtract away 144. And that's going to give us 2,400, 2,400, and we need the square root of 2,400. So let's find that. 2,400 raised to the 0.5 power. By the way, if you don't have a square root feature on your calculator, but you can raise something to another power, raising things to the 1/2 power is taking the square root. So the 1/2 power of any number is its square root. And that's what I'm going to do right now. And the answer is, that's an interesting one. 48.989, blah, blah, blah. We got to round this to the nearest tenth, which is where that 9 is. But the number in the hundredths place is an 8, which tells us to round the 9 up. So what's my answer going to be? 49. 49.0, but yeah, 49. So it's 49 inches. The TV is 49 inches tall. So the thing is, if one store was advertising the same TV as a 49-inch TV, and another store was saying it's a 62-inch TV, you'd say, oh, I want the 62-inch, even though it's the same TV. They're just giving you a different dimension. Okay, let's do the last one. The area of a rectangle is 36 square units. So they're not giving us any specific unit. So the area is 36 8 square units. That's a little different. They're giving us the area, the space inside the rectangle. Its width measures 4 units. Find the length of its diagonal round to the nearest tenth of a unit. Okay, so let's see what we have. We have the area of the rectangle. Width measures 4 units. They want us to find the diagonal. So let's make yet another rectangle. And we're talking about the diagonal. I'll just draw a diagonal there. All right. I know the width. The width, they say, is 4 units. I'm going to put that 4 there. But they say the area is 36. Square units. And that's a part, what we would like is, well, obviously we want to find the diagonal here. But the diagonal isn't 36. Yeah. Well, the diagonal is the space inside. But remember how we find the area of a rectangle? That's the perimeter. And we want the length. We want this side, because then we could use the Pythagorean theorem. I don't have the length, I have the area. I have that this is 36. And then I have the width, which I do multiply times the length, which is 4. How did you get 9? Yeah. So we have to divide 36 by 4 to get the length. So we had to do a little side work to get that, because now we could use the Pythagorean theorem. We got 9 for A, 4 for B, and C we will figure out. So let's do it. A squared plus B squared equals C squared. So 9 squared plus 4 squared equals C squared. Okay, so 9 squared is 81 plus 16 equals C squared. And so that's going to be 97. Well, let's take the square root, because that's the square root of 97 is going to be that diagonal length. Now I know the square root of 100 is 10, so it has to be less than 10. It's 9 point something, but 97 is pretty darn close to 100. Yeah, about 9.8 maybe. That's a very reasonable guess. Let's check. So 97 raised to the 0.5 power. Boom, look at that. If we round it, it is 9.8. Okay, so the diagonal is 9.8 units.
That's rounded or?
Mm-hmm. 9.8 was a rounded answer. There you go. All right. So on if two things. I have the glue sticks if you are keeping this in your notebook. And the assignment is on Delta Math. You have some questions just like these. Okay.